All right, IBSL1, we've come to the end of chapter 12. So today we're going to wrap up sinusoidal curves and do some closure notes. But before we get to closure notes, I thought we'd do one last kind of all-encompassing example, maybe one of the more difficult problems I can think of in terms of graphing a sinusoid by hand. So our task, without using a graphing calculator, just sketching by hand, we're going to graph this right here. There's a few things to notice about it, like, for instance, here, this is our amplitude. That's the distance from the center line up to the top and down to the bottom. Even though that's a negative value, it doesn't mean the amplitude is negative. The amplitude is still just positive 3, because you always take the absolute value of that number out in front of the cosine. The negative just means that instead of a regular right side up cosine curve that starts at the top of the mountain, it's actually going to be upside down, and it's going to start at the bottom of the valley. The next thing I notice is this +1. This is going to be your midline. The center line, the home base, whatever I call it, it means that it's like centered around that. Based off of those two things, I can actually set up my sort of training wheels for this curve. So here, I'll do my training wheels in like a gray. The center line is at +1. So let's just say, what do we have to go up 3? Yeah, let's say every block is a tick mark. So here I'm going to put my center line on y = 1. And then I'm going to go up 3 and down 3 from that. So it's going to get up to +4. And then down 3 from that means that it will get to -2. So our entire curve will live within these gray lines. The other thing that I did before I started this video is I saw that this has to go from -pi all the way up to 2pi. So I started kind of, just pre-graphing in my head about how it should look. It should go from, -pi all the way up to 2pi. The next thing we need to consider, so we already know it's an upside down cosine curve, but there's a couple things going on inside of here. This 2, it's not the period itself. It's not a period of 2, but period equals 2pi over b. So if we're going to find the period, it's 2pi over 2, which means this curve is going to repeat every pi units. Now, if you look at this and you see this +pi/4, this is the horizontal shift, but it's not the actual horizontal shift. It's not pi/4 to the left or right, because there's a horizontal squish happening, a horizontal compression. So there's two ways to think about this. You can think about the pi/4 shift being squished by a factor of 2, or one thing I like to do is put this into factored form. So if you were to factor this inside here, you would pull the 2 out and then have x plus something afterwards. So then you think to yourself, 2 times what in this space will give me pi/4? Well, if you're going to multiply a number times a fraction, it would go into the top and then the fraction would reduce. So that means, oh, I didn't mean for this to be like this. Hold on, let me think. I'm confusing myself now. Yeah, it would be plus pi/8 there, but I don't want to go by pi/8. Oh, I guess I do have room to do pi/8. All right, let's give it a shot, see how it goes. I think I meant for that to be a pi/2, so then we do a pi/4 shift. Yeah, you know what? I'm going to change it. So let's say that it was actually pi/2 here. Now, pi/2 is not the actual shift. You have to kind of put it into factored form and think 2 times what will give me pi/2? Well, that means that a factor of 2 gets canceled out in the denominator. So that means that this is actually plus a pi/4 here. The other way to think about that is that it's a shift of pi/2, but before you do the shift, you have to compress it by 2. So it's actually not... it's like dividing it by a half, the same way that the period gets halved. So it's like a pi/4 shift to the left. So now I'm going to do like a second set of training wheels, because pi/4 to the left is like right here. Pi/4 would be this. But it's an upside down cosine curve. Upside down because of the negative. So my first dot on this curve is going to be right here. Now I know that every pi units it will repeat because the period is pi. So normally pi would be from here to here, but if I shift that yellow line over to the left by pi over 4, that means it'll go from here to here, that this will be one full period. So this is a distance of pi. So halfway in between that, it'll hit the top of the mountain, which means at pi over 4, it'll hit up here. And then you can start to do like your, every quarter that it either goes back to home base or into the valley or up to the mountain. So here at 0, it'll go up to home base. So then it'll go up the mountain, then back down at pi over 2, and then down to here. So that's one full period of this curve. It's an upside down cosine curve. It has a period of pi. It's been shifted pi over 4 to the left. It's got an amplitude of 3 and a center line of 1. Now, this is great, but the directions say that I have to graph it from negative pi all the way up to 2 pi. So I just have to continue this pattern, that every pi over 4, you're going to get one of those major changes. So it'll go up to here, then to here. Nope. Here. Back down here. So like every 2 blocks, it goes through those major changes. So. And same thing on the left. I have to go all the way out to negative pi. So that means every 2 blocks, I'll go back to home base. Then 2 more blocks, I'll go up to the top. And 2 more blocks, I'll go back to home base. So here's what my curve would look like. And these would continue. If I want to be a real stickler, there should be arrows on the ends of these. And then technically my training wheels are not part of the graph. So you can actually go in here and erase these if you want it to look proper. They just help me make a really nice graph. All right, that's about as complicated as it gets. Also notice if I just given you this picture right here and asked you to come up with an equation, doesn't that look like a sine curve? It looks like a sine curve that starts here and goes from here to here. So if it was up to you about what equation you could write, if I didn't say to write a sine or a cosine, you could just write a sine curve for that that's been shifted up by 1. But if it said you had to write a cosine for it, then there would be some sort of horizontal shift involved. If you were to write the cosine, I'm getting so deep here, it could either start here and go this way, which means that it was shifted pi over 4 to the right, so that it'd be a minus pi over 4 inside the here. Or you could see it as an upside down one that starts here and goes like this, or there's a lot of different ways to see it. Close your notes. You should be very familiar with the sine and cosine parent curves, what they look like, their amplitudes, their periods of 2 pi. Both of these equations, I should be able to give you an A, B, C, and D value, and you should know how that affects the picture. Remember, A controls the amplitude and whether or not the curve has been flipped upside down. The D value controls the midline. That's like your vertical shift. The C value is your horizontal shift. Remember, that's backwards of how you think it should work. And that the B value controls the period. Here's some quick handy ways to remember how to find amplitude, period, and midline. These also really help out with the word problems. So I'm going to put that here. Amplitude is the top minus the bottom divided by 2. Period is 2 pi divided by b. The midline is the top plus the bottom divided by 2, or the average of the top and the bottom. I would also know how what the parent equation of the tangent curve looks like. That's not a highlighter. So know that that's the one that looks like the noodles or the chairs that are all pointed to the left. It's got a period of pi. Know its x-intercepts and its period. Also, that one involves asymptotes. The last thing we did was real-world modeling, which means taking some sort of word problem and then translating it into a sine or cosine model. The main thing I want you guys to be able to do is to either reason through the word problem and then come up with the equation, or start with a data table and then come up with the sine or cosine equation. Remember that a lot of those skills are going to involve this stuff right here. That's all I got for you guys. Happy studying. Good luck tomorrow.